All right, it's with great pleasure that I now introduce our next session, which will provide national perspectives on visions for science and technology and current challenges that we face. This session will be moderated by Mr. Dale Redding, whom we've already heard from, so he needs no introduction. Please join me in welcoming him.
I would invite our two distinguished panelists to come up. It is my absolute pleasure to introduce both Jeff Singleton from the US and Emmanuel Chiva from France. If you just indulge with me just for a moment, I will provide their bibliographies, and then I will invite each in turn to come up and give 5 to 10 minutes worth of perspective, and then we will open the floor for questions. So with that, I will start with Jeffrey D. Singleton, Director for Technology, Office of the Assistant Secretary of the Army, Acquisition, Logistics, and Technology. Jeff Singleton is a member of the Senior Executive Service and currently serves as the Army's Director for Technology with oversight of the basic, applied, and advanced technology development research programs at Army laboratories and engineering centers, comprising programs at the Army's Future Command, the Army's Research Institute, the Army Corps of Engineers, and the Space and Missile Defense Technical Center with a combined annual budget of approximately $2.5 billion. Mr. Singleton also represents the broader U.S. research and technology enterprise as the national principal member on the NATO STO board. He began his career as a research engineer with the Department of the Army, specializing in the field of analytical and experimental rotorcraft, aeroelasticity, aeromechanics, dynamics, and structural mechanics. His extensive background in science and technology, investigation, and oversight spans more than 3 decades of fundamental research, advanced technology development, and acquisition. Mr. Singleton earned his Bachelor of Science degree in Aerospace Engineering from West Virginia University, where he graduated magna cum laude in 1984. He also earned a Master's of Science in Aerospace Engineering from the Georgia Institute of Technology in 1988, specializing in rotorcraft aeroelasticity. Mr. Singleton is a recipient of the Department of the Army Superior Civilian Service Award, the Army Research Laboratory Honorary Award for Leadership, and the American Helicopter Society International Award, Howard Hughes Award, as team leader for the Army NASA Bell Quad Tilt Rotor Aeroelastic Test Team, given a recognition of an outstanding improvement in fundamental helicopter technology. Mr. Singleton has authored more than 70 journal articles, scientific conference publications, and invited presentations. He is married to Paula Singleton and has 2 sons, Nathan and Hayden, and is a native of Charleston, West Virginia. I will invite Mr. Singleton to speak, and then Dr. Shiva, I will introduce you immediately after.
Dale, thank you very much, and thank you to John Michael for hosting this event and the NATO Collaboration Support Office. I think it's very critical. So today I'm here not just representing the United States writ large, the science and technology enterprise writ large, but also Ms. Heidi Shue, the Honorable Heidi Shue, who is our Undersecretary for Research, Undersecretary of Defense for Research and Engineering. She regrets that she could not be here in person with you, but she asked me to speak in her place. So thank you for that, and merci. Again, thank you to the NATO for hosting a great symposium celebrating 70 years of science and technology, and for the opportunity for me to share with you the U.S. science and technology vision and response to S&T challenges. Today, we face a critical moment to prepare for the future of warfare. That future of warfare is technology. For NATO to continue to be relevant, it must learn from the past, adapt to the present, and invest in the future of technology. China is investing in robotics, new energy vehicles, biotechnology, aerospace, and wants to become the world's primary innovation center for AI by 2030. Space is a contested domain today. According to an April 2022 Defense Intelligence Agency report, between 2019 and 2021, the combined operational space fleets of China and Russia have grown by approximately 70%. The bulk of that from China. I am here today to make sure we maximize our partnerships and information sharing to make sure that we jointly are technologically superior to those that threaten democracy and human rights around the world. The Russian invasion of Ukraine has amplified the criticality of increasing our collaboration with allies and partners to deter aggression, strengthen our technological superiority, and maintain our military advantage. This is of particular importance to the NATO science and technology community, incentivizing us to think how we can get our technologies to our warfighters faster, transitioning from a project to a program of record that leads to capabilities, the most critical aspect. Our strategic competitors have been investing heavily in developing capabilities in many technology areas, including hypersonics, space, nuclear, cyber, and AI. There is greater access today than ever before to commercially available state-of-the-art technologies, such as microelectronics and unmanned aerial systems. We cannot afford a leveling of the technological advantage. This is why our combined efforts in the NATO Science and Technology Organization are so important. As you know, the United States has been heavily involved, indeed invested, in the NATO STO for many years. Of the over 5,000 researchers in the alliance, the US participants number more than 1,000. And as I like to always point out, they come from not only the Department of Defense and the military services, but from across the US government, industry, and academia. That is why I always say, as I am the US principal voting member to the NATO Science and Technology Board, that I represent the United States. As the Department's Chief Technology, Ms. Xu, has sought to strengthen and promote the defense science technology as well as innovation within DoD by implementing numerous programs that encourage prototyping and joint experimentation. The Department supports NATO's efforts to leverage centers of innovation to meet NATO's operational requirements. NATO's Defense Innovation Accelerator for the North Atlantic, DIANA, seeks to accelerate the development of solutions for dual use and emerging and disruptive technologies and challenges through innovation. DIANA's focus on multi-sector participation will shine light on small startups, mid-sized companies, and academic institutions that otherwise lack the exposure needed to gain recognition on a national or international level. This will strengthen both NATO and the US innovation communities, providing the best and the brightest scientists and engineers with a platform to showcase their talent. Another initiative that the Department of Defense supports is called the Rapid Defense Experimentation Reserve, or RADER for short. RADER is a continuous campaign of joint experimentation. Again, Ms. Xu's office took a scenario of interest by the Secretary of Defense and worked very closely with our joint staff and combatant commanders to figure out how to close the joint warfighting capabilities gaps. The first sprint for RADER will be conducted in FY23. For that sprint, in a 5-week period, and I was part of this effort, directly part of this effort, we reviewed more than 200 white papers, again within 5 weeks. Those are ideas that came from across our services, across our S&T community. The research and engineering team assessed all those ideas within the white papers, prioritized them in order of joint capability gaps, and recommended the top 32 projects for funding. Ms. Xu met with all the services, again with the joint staff combatant commanders, the vice chairman of our joint chiefs of staff, and the deputy secretary of defense, and provided those recommendations, and received a thumbs up across the board to actually fund those, again, asking Congress for funding to begin in FY23. This is the very first time that the Department of Defense is focusing on joint capabilities instead of service-specific capabilities. And it is incredibly important, as we do not fight as services, but we fight jointly, and we fight jointly with our international partners. R&E is planning to conduct 2 more of these sprints starting in FY24, just in the same way we conducted the first sprint. And the second sprint, we will open it up to industry and across the entire DoD research and engineering enterprise. I just want to note that out of the first 32 projects that are expected to be funded, pending congressional approval, 3 of them are with our allies and partners. That speaks very strongly of the importance of combined efforts. In addition to looking for innovation, we recognize the need for our laboratory and test infrastructure, because we know that we're going to need additional funding to make sure that our infrastructure is aligned with our strategy that is moving ahead. We are also engaging with venture capital firms to better communicate our desires and understand their perspective. We can leverage the power of partnerships and accelerating technology development by working with allies, our allies and partner nations. And the goal is to accelerate the ability of our collective science and technology communities to innovate, experiment, and transition capabilities together much faster. We're seeking to understand areas of mutual interest in initiating joint research and development activities with other partner nations as well. Our asymmetrical advantage is to share our mutual insights, collectively accelerating the development of joint capabilities. Recently, as noted, Honorable Xu laid out her strategic vision and critical priorities. These 14 critical technology areas have been divided along 3 major categories. These categories encompass those areas that are emergent, potentially breakthrough technologies. The second area is those areas that are where there is effective commercial adoption. And the last category is those that are defense-specific in nature. Examples of the emerging technologies include biotechnologies that can increase sensing and avoid surprises of infectious diseases, also reduce logistics burden and sustainment costs in a contested fight. For example, last year in Guam, using biotechnology, DARPA took water and sand, and in 48 hours was able to create a helicopter landing pad. Exactly what we need in a contested fight. Quantum science that can provide much more precise precision, navigation, and timing, as well as quantum computers. Advanced materials that are stronger, lighter, and afford better protection for our armored platforms. And we are also starting to focus on future generation wireless technologies. Not 6G, not 7G, but next G. Again, we can shape the future standards and develop enhanced interoperability. The second category I mentioned is where the commercial sector actually leads, and there's a vibrant commercial sector, but we need to leverage that. Trusted AI and autonomy and autonomous systems is one area of that. Integrated network systems of systems to enable targeting and tracking and acquisition by inter-sensor and engagement by inter-shooter. A more hybrid, more proliferative space technology to enable resilient cross-domain operations. Renewable energy and generation and storage. As Honorable Schaefer just mentioned, that the department is absolutely looking at how we can actually address renewable energy and storage considerations to decrease warfighter vulnerability and deliver new operational capabilities for DoD. Advanced computing and software technologies. It's almost ubiquitous, supercomputing, cloud computing, data storage, computer architectures. We must leverage the best commercial processes into our software processes within DoD. 70% of our microelectronics come from Asia, which poses a significant supply chain risk, which we have been experiencing for the last 2 years. Our Congress is very interested in helping our microelectronics industry to reshore our microelectronics foundries to better protect our supply chain. As we saw from the young scientists too, it's not just the hard sciences, but the social sciences as well. Ease of use of human-machine interface is critical to reducing training for our warfighters and users, understanding when they're getting into cognitive overload, as well as understanding other cultures and how different folks bring biases or their own cultures. So we can improve warfighter performance by understanding that area as well. Finally, the third category focuses on defense-specific areas. Directed energy. Directed energy has finally matured to the point where we're starting to field systems, and they are a critical part of our layered defense strategy. Hypersonic missiles have the ability to dramatically shorten the flight time and provide extremely high maneuvers in the terminal phase of flight, and they are very difficult to counter. So we're trying to develop leap-ahead technologies for our operational forces. The last technology area is the integrated sensing and cyber into a single system. We're trying to develop and must develop wideband sensors to operate at the intersection of cyberspace, electronic warfare, radar, and communications to enable operation in a highly contested environment. And we're moving out forwardly aggressively in this area. In closing, we can collectively leverage the power of partnership in accelerating technological research and development by working collaboratively together. We have a tremendous opportunity and an urgent need to align our priorities as Russia's unprovoked and unjustified invasion of Ukraine demonstrates. We are far stronger if we work together. Now I want to go a little bit beyond what Ms. Xu actually wrote for me and pull 2 threads from this morning. You know, there's a history discussion to be learned here. And I am fortunate to have an opportunity to speak to many university students, high school students. As an engineer, I recognize that I didn't learn enough history in school. So we have to bring that next generation in. And how do we do that? We have to do a better job of promoting the fact that in defense industries, we have really hard science and engineering problems to solve. That's what brought me into the government system. That's what will bring our next generation into the next system, into the system as well, even if it's only for 5 years. It's also, as Dr. Citano pointed out, we have 70 years of S&T in history with NATO. It's incredibly incumbent on us to recognize that and to build on that foundation, because it's extremely critical to us moving forward. And understanding that impact is incredibly important. And then the last thing I want to pull is something Dale mentioned this morning too. We all have emerging and disruptive technology areas. In the US, we have our own critical technologies list, 14 of them, as she pointed out. What I always look for, there are so many similarities between them. I look for the what are we missing? And Dale alluded to it this morning, right? What I think is missing is the unexpected convergence of these research areas. For example, quantum computing, quantum simulation will allow us to analyze biotechnology and synthetic biotechnology to advance and create novel materials assembled at the nanoscale to create nano devices. How is that going to impact our future? And how can we avoid that technology surprise? So with that, thank you very much. I do appreciate the opportunity to come talk to you today.
It is now my distinct pleasure to introduce Dr. Emmanuel Chiva, Director de l'Agence de l'Innovation de Défense. Emmanuel Chiva has been appointed Director of the Defense Innovation Agency effective September 1st, 2018. He is a member of the Directorate General of the Armaments Executive Committee. A graduate of the École Normale Supérieure, Emmanuel Chiva holds a doctorate in biomathematics with a specialization in artificial intelligence and in the field of complex systems and biomimicry. Age 52, Emmanuel Chiva has worked for more than 20 years in the fields of artificial intelligence and military simulation in several companies. In total, Emmanuel Chiva led 13 startups before joining the French Ministry of the Armed Forces. As head of the Defense Innovation Agency, he has leveraged his experience in the world of entrepreneurship and startups to implement an open innovation approach towards the civilian innovation ecosystem, creating a one-stop shop and a project-oriented organization serving defense innovation. He created the Ministry of the Armed Forces Defense Innovation Fund, endowed with 200 million euros, and aimed to take stakes in innovation and dual-use companies in the development phase. He also imagined and created the Red Team program, an experiment bringing together science fiction authors and scriptwriters to imagine futures and anticipate strategic surprise. In 2019, the Minister of the Armed Forces awarded him the insignia of Knight of the National Order of the Legion of Honor. Dr. Shiva, the floor is yours.
Well, thank you very much. I will begin by saying happy birthday and good luck. The happy birthday is for you. Good luck is for me, because I know what it is to speak after lunch and trying to sleep in a room when somebody is making noise. Anyway, so I'm deeply convinced that the performance of defense innovation relies on the existence of a global ecosystem, of a community that reflects on the challenges and opportunities that are posed by disruptive technologies. So thank you very much for having invited me here. It's a real opportunity to remind us that a solid and dynamic innovation policy is the key for the preparation of future conflicts in all their forms and in international contexts and permanent evolution. I won't get back very long on the current situation, the fact that we see the return of the power states, the fact that we knew sea, air, land, now we see space and seabed as possible battlefields, and other fields of confrontation such as informational warfare, cyber warfare, or cognitive warfare, and we'll get back to that. We see also the coexistence of high intensity and asymmetric warfare. And, in France, the Chief of Staff published a vision in which he says that we went from the classical triptych, that is peace, crisis, war, to competition, contestation, confrontation, which is not neutral, by the way, because you see that the word peace has disappeared. So we, at the same time, witness an evolution in terms of defense innovation and civilian innovation. I don't know if you remember, but 20 or 25 years ago, communicating on the battlefield was the privilege of the military. Sending objects into space was reserved for states or state companies. So now we are challenged in those domains, and we are challenged by actors which financial surface is greater than some states' surface. The R&D budget of a company like Alphabet or Huawei is around $21 billion a year. The budget defense of a country like Israel is 17. So that gives a view on the world that we are living in today. So innovation is not an option, it's a never-ending effort. We must absolutely remain on the edge, and this is why France has decided to engage into a very dynamic innovation policy. So, sorry, I don't see anything because of the lights, so I understand your remark here. I feel like I'm a suspect somewhere. So the role of the French Defense Innovation Agency is to provide orientation, provide guidance, act as a control tower or orchestra conductor for innovation, and also to go on to see the civilian world, civilian ecosystem, and try to adapt, both in terms of technological maturity and user maturity, innovation that comes from the civilian sector. So in this context, we have €1 billion per year to conduct this innovation policy, which is a significant improvement because in 2017, before the actual military programming law, it was 700 million per year. So it's quite a drastic increase. And in this context, the agency is conducting several significant projects and major strengthening strategies around high-interest transverse technology issues. So I will give you some example. First one is about the enhanced soldier, the improved human. We must, and it has been said, work for the improvement of the soldier. The human is at the heart of every conflict. And we work on several types of enhancements. First of all, to regenerate. Regenerative medicine to repair war injuries is one of our main priorities, should be a main priority for innovation. To give you an example, we recently presented a project where we use 3D printing to be able to print skin and cartilage directly on a soldier that suffers severe burns, which is something that we must focus on because the severe burns, that means 70% of the body, is 10% of our casualties. But it's 0.1% in the general population. So if we don't do it, nobody will. Enhanced soldier is also about, augmented reality, brain-computer interfaces, non-invasive brain-computer interfaces, cognitive monitoring. But you need to be cautious, so France has decided to create, and I think it's the only European country which has done so, a national defense ethics committee to make sure that we don't cross any ethical red lines. Second area is obviously robotics, cooperative, collaborative combat, what we could say the cybernetic teammate, that is the complementary capabilities of the operational staff, operational user, and robots to contribute to operational superiority. So the idea is to encourage technological developments in the field of artificial intelligence, environmental understanding, multi-sensor fusion, cognitive sensors, and to improve the autonomy of systems to allow a real mix of human and robots, autonomous system within an operation unit. We actually send some robots in operation in the Sahel region to see how they could cooperate with human soldiers. And it's always very very interesting to organize real-world experiments. We recently organized a challenge called COHOMA for human machine. It's a French acronym for human and robot cooperation. And the idea was to see how we could, in an unstructured environment, cooperate between human and robots. And just as an anecdote, because I come back from Orleans, there was a demonstration of this challenge by the French Special Forces, and they use, those dog-like robots. Not the one from Boston Dynamics, another one, because this one is expensive, to see how it could be used in operation. And actually, they did this on a farm, and there was a real dog who began barking, really barking. And he was barking not because the thing resembled a robot, but also because he uses ultrasounds to be able to identify its environment, which is very important for us, because if you use it in the real world and you have an operational units with dogs, this will have the same effect. So it's really important to put things in situation and see what happens really when you mix humans with robots or dogs. Third one is technological perception. I would say God's view versus invisibility. The enhanced human or the cybernetic teammate must be able to evolve in an environment they control. And this advantage concerns technological perception and the ability to see better while being seen less. So we work on intelligent sensors, of course, with embedded artificial intelligence capability to be able to process locally the information without having too much of a need in terms of bandwidth. But also to have real invisibility cloaks. So we're working on meta-surface, meta-materials, very low TRL, deep tech, but also multi-spectrum stealth for armored vehicles. And we have two projects. One is called Chameleon, the other Salamander, to mature technologies in those areas. Defense innovation is also about aggression. It's also about fighting. We should not forget that. We talk a lot about digitalization, but we should talk also about weapons. So the electromagnetic weapons, the ray guns, that could be able to stop hypervelocity threats are obviously a major issue for us. But as well, we're working on directed energy weapons. This is one of our national priorities, especially to counter UAVs. And we have, I don't know if some of you will be able to come to the Eurosatory show, which takes place this whole week, but we show an experiment and the result of an experiment using laser technologies to counter small drones, neutralize some small drones, and I can assure you that after that they work a little less well. And then there is cognitive warfare. I'm not saying that because it has been described during the previous sessions, but I really think it's a threat to our democracies. And actually, I think with that adversarial attempts to manipulate human behavior will constitute a major challenge. And it goes beyond simply controlling the flow of information. It's about how we can influence, change not only what people think, but what they feel and on how they act. So we launched a new project called Myriad, which is obviously classified, to examine how we can counter those threats in terms of controlling emotions, controlling the smell, controlling perceptions, controlling cognition. And then we have to make sure that we use artificial intelligence to detect and counter, for example, information manipulation. But if you want to use AI to detect such a scheme, you need to be able to trust the AI you use. So there are major challenges in Truthworthy AI, in also explainable AI. We don't want any black boxes, but also we want to be able to learn with a few amount of data, so frugal AI is also a challenge. And this is, by the way, something that we discuss with the French research, between the French research and innovation agencies and the US agencies such as DIU or DARPA. And then there is the intellectual agility. To perform in innovation is to have a specific mindset. Hence, what you described, the Red Team project, that is a project that brings together sci-fi authors, writers, drawers, actually, artists, to be able to imagine the world in 2060. See what could be the threats at our capability horizon in 2030, and then get back today and ask ourselves the question, what can I do to prevent this from happening? We already did 2 seasons of this experiment. The third one will be unveiled next week. There is a classified version of the scenarios and an open version. So it will be unveiled the 23rd of June in just 1 week. And actually, the Myriad project, the cognitive Wi-Fi project, comes from a scenario, a very scary scenario of the Red Team authors. We asked the Red Team to be able to make sure that we don't sleep at night. I can assure you that they do their job very well. Now, to conclude, beyond defining priorities in terms of disruptive technologies, we must also generate a strategic advantage elsewhere through the ability to capture open innovation, to incorporate them into very complex systems that take years and decades to mature, thanks to duality. But remember that duality is an opportunity, it's also a threat, because innovation becomes available to everybody, including our opponents. And we need to implement flexible modes of action that allow us to integrate innovation with a high degree of reactivity. And I'm talking also about what innovation can we do in terms of purchasing, administration, which are not technological breaks, but can act as breaks for the diffusion and acceleration of defense innovation. So the challenge is to shorten technological maturation cycle, to accelerate the integration of innovation into armament programs. If we wait for the maturity of the disruptive innovation that we discussed today, before integrating them, we will have to wait about 10 years. So we need to make room for innovations and technologies that we don't know, to make sure that we can integrate them into armament programs that take 30 years. And this is a real challenge. So we must learn from the past, we will learn from the current crisis in Ukraine, but we also need to be cautious. We should not sacrifice preparation of the future to the emergency of the current situation that we know today. So it's very important not to overreact, hence the importance of structures such as the STO to make sure that we continue investing in the future. Thank you.
We'll now move on to the questions. I have one question to kick things off, and then we will open it up for questions from the audience. Hopefully, we'll have some interesting, challenging questions here. So my first question is really to both of you. In your opinion, and we've talked a lot about EDTs, large sets of them, but in your opinion, what are the 3 most critical technology or scientific areas that we must get right if the US, France, and NATO writ large are to maintain that technological edge that we talk about? And if you could, in your answer, could you sort of look at it from a 5-year perspective and then a 20-year perspective?
Well, I could go for the easy answer that they're all important. However, I really want to break this down in 2 different ways of looking at it. First, if you look at individual disciplines, as a researcher, I have my own personal favorites. Everybody will. But what scares me most, again, as I pulled the thread this morning, biotechnology, synthetic biotechnology, which you can develop processes at ambient conditions. So almost anyone can do them in their garages. So in the near term, that could be very dangerous. Even in the long term, what we might develop. Quantum sciences, I think, has tremendous aspect and is truly critical to me, as well as material science. I think fundamental material science underpins everything. The other way of looking at this is again, how Ms. Xu has categorized it. There will be emergent technologies which we must invest in, but the defense sciences and our defense community must really invest in those. There's the middle category where we must leverage the vibrant commercial sector for what they're doing, particularly in the areas of software and cyber, because the spin cycle for what can be developed is so fast and relatively inexpensive that can go fast, and how do we keep up with that? And then the third category is defense specific. So again, in the 5-year, in that perspective, within 5 years, we will certainly have to, and we are fielding certain things in directed energy as well as hypersonics that will need to come to bear. Those will also play again 30 years from now, 20 years from now as well. What is the next generation for hypersonic flight capability and maneuverability? Where in the world will we be with future G and communications technologies, from undersea to land to air to space to in 30 years to the moon or Mars, and how does that play into maybe more so an economic presence around the world or around the solar system? Those are kind of my thoughts on that area. Emmanuel?
Well, I don't know if I will answer your question, because I don't know if it's 3 critical technologies or more of the way they can be mixed together in a disruptive manner. But I will try to answer. For me, short term is about robotics and swarming and UAVs, and how we can neutralize that. And if I talk about UAVs, not only the UAVs, the control stations, the batteries, the autonomy, it's the data link, it's the armament. So it's a real challenge, and we see on the battlefields today that the use of derived UAVs from the civilian world is something that is very concerning. For me, the most critical in terms of sovereignty and threat to the democracy today, the most critical technologies and area that we must master is cognitive warfare. I really think so. I really think it's something you can learn also for the current situation. At the beginning of the Ukraine invasion, we had a combination of a cyber attack on the TV networks and the diffusion of a broadcasting of a deep fake of Zelensky asking to let down the arms. So this is something that will affect us in every domain, and mixes AI, biology, psychology. We should not oppose hard sciences and soft sciences. I mean, today we need the combination of all we know in the comprehension of the human environment to be able to be effective in this field. And if I look at 20 years, still try to answer your question. 20 years, I will say saying that quantum technology is a real disruption. AI is not a real disruption. The real disruption is that it works. Quantum technology, there will be a before and an after in the field of quantum sensing, obviously, which is something very specific for defense, but also in the field of the quantum computer. You know that there is a Chinese Manhattan project that the philosophy of which is store now, decrypt later. So the day a superpower will have a quantum computer, not only will be able to decrypt a massive amount of information, but he won't tell it. And that's a real threat. So we need to accelerate on those technologies, I think.
Thank you for that response. What I'd like to do is open the floor up now for questions from the audience. So please, we have a question over here.
Thank you very much. My name is Rudy Bream. I'm the chairman of the NATO Industrial Advisory Group, the NIAC. First of all, happy anniversary as well for the 70th anniversary of the S&T community within NATO. NIAC is only 55 years old next year, so we are much younger. But even within the NIAC, we are looking for young people. So if you want to join the NIAC community, we welcome as well. I heard Diana, and we're going to talk about Diana later on as well, probably, but looking at, because I heard numbers from Dr. Shiva, like what's Huawei and Google, what they are spending, what DARPA is spending, and then we look at Diana with challenges and some money that will go to startups and small and medium-sized enterprises. Some people are wondering, will that money be enough? Because the output of Diana will be based on input, and it's not only humans, startup, it's money. So my first question would be to both, will there be enough money in those first 3 phases, because it's paid by the 30 allies? My second question and last question is, then there's the Innovation Fund. I heard that 21 nations so far signed the letter of intent, and I heard that France and the US so far didn't sign the letter of intent. So I was just wondering, will they join later on, or is there a reason why they didn't join yet? Thank you.
No, you have to speak up, so go first.
Well, I'm going to dodge, basically. The policy questions are above my head. Will we join or when will we join? I don't know. But let me get after your point. Is there enough money in innovation and reaching out to the smaller communities? I think that's a problem for all of us, our partner nations and allies as well. And so every avenue that we can use to reach out to the community is good. So while I'm not going to, is it enough money? I don't know, but it's more money. Right? In the U.S., we have, and particularly under the new administration, we have taken significant steps to increase our outreach to the entrepreneurial community, small businesses. We're reinvigorating our small business innovative research program. We're hoping Congress will reauthorize it soon because it's set to expire at the end of this fiscal year. But is it enough money? I don't know, but at least it's more money that's going into it. And I think that's critically important because we must reach out to these communities and keep it going.
Well, the question you ask about money, people ask me the same question for France. Say, okay, you're happy because 1 billion euros is a round figure. Yeah, 2 billion euros is also a round figure. So yes, it's already regarding Diana. It's good that this initiative takes place. In terms of competition, I would say it's complete, not compete. So it's obviously a complementary initiative with respect to European initiatives, and we discussed that in Brussels like 2 months ago. So it's a good opportunity. Said that US and France actually didn't respond, but we responded with proposals last week to give you some first information. And let me remind you that the vote on Diana was unanimous, so there's no question about whether it's interesting or not.
Any further questions? Well, with no further questions, I'll ask one more, actually. Was there one over? Was there a question over there? My apologies. You're not on my line of sight. My apologies.
Well, you did mention that you weren't seeing much, so sorry, I'm in your blind spot. Since you mentioned budgets, and we're living in a very unique macroeconomic environment, I wonder if, and we do have seniority and high decision makers in the room, so I'm just going to launch a question that is directed to, we have Diana, we have budget within the EU also for the EDA, which covers even the budget of Diana. We have a new budget for defense coming into play, and then we have the ECB and the Fed and all the banks cutting all the funding, increasing interest rates. Companies are going to basically have lower access to fresh money, and they will be supporting on their own debts. So I wonder if this will have a backlash on the money, on the funding that is being supported for Diana, and then if along the way, in 3 years' time, if we have enough budget power to address the elephant in the room, which is the technology development that NATO and the allies need to push forward in the coming years. Thank you.
I'll start, but I'll answer from a U.S. perspective. Both the previous administration and this administration actually have increased defense spending, particularly in research and engineering, more so in the program of record side, actually buying and modernizing equipment. The research and engineering, the S&T budgets have been relatively stable. I don't see them going down, but we are going to be overtaken by inflation. And until that changes, I don't know, is it a real increase or not? And everybody's going to have to answer that question. Yes, the money going into research and technology is increasing, but is it commensurate? So, and I don't think anyone really knows the answer to that question yet.
Well, it's very difficult to answer your question because I don't know how it will evolve. And by the way, one comment you say that due to the increase in funding, companies will have more access. Now, there is still a problem with the financing of defense-related activity by banks. And there are some people in Europe and elsewhere that are willing to put into place some kind of a taxonomy that will prevent companies and startups to leverage money when they try to develop a program or a project related to defense. And the President of France, Emmanuel Macron, Monday, during the inauguration of the Eurosatory trade show, made a good comment on that. So we will be very, very cautious not to let this kind of lobbying consider that the financing of defense is the same as the financing of pornography. Because it is the case right now in terms of what I can tell you, there is a real will to increase budgets related to defense R&D and science. I'm speaking for France. I don't see any hidden effect or backlash in the next 5 to 10 years. It's a matter of global security for all of us, all allies. France is willing to take its parts. So no, I don't think any backlash soon. Maybe I will be mistaken. I can tell you that at least in the next 5 years, it won't take place.
Well, thank you very much. Please join me in, again, another round of applause.